What is BIM? If you have been working in the construction industry, it's almost certain you came across that acronym. Maybe to you it means some sort of smart 3D model. Many people are confused about what BIM really is. One of the reasons is that the language around BIM seems so complicated with all these fancy acronyms. You don't need to understand all this jargon to know what BIM is. This video aims to explain BIM in the most simple terms. I am Nicolas Catellier, architect, BIM manager and founder of the website Revit Pure. I am with Eli Gould, a wood structure expert from the Quebec Wood Export Bureau.
So today we're going to talk about, we're not going to call it BIM for Dummies, but we're going to talk about what is BIM and how did the origin of this tool really come to bear. So you are a Revit expert and I come from a CAD/CAM background, so we're going to compare notes on how this has gone forward. So thanks a bunch for coming.
Thanks.
Drafting was the first thing, and if something was automated, the big deal was computer-aided drafting, right?
Yep. Well, I like to look at old images of an architect's office. And you always see all these people in white shirts that are drawing manually all the plans. But then the next evolution would be CAD, the first version, as you can see in this image, with using software such as AutoCAD and others.
But that was right when I first came into practice, and I remember being a little bit disillusioned. I was like, well, wait, I'm sitting at a computer, but I'm drawing lines, and I'm not sure that I'm a 3D thinker. I'm not sure this is the right thing for me. So I was really excited I would say for my practice in the late 90s when I began to see like 3D modeling is coming on. This is a thing. You're going to sit at a computer and you're going to model something in 3D, and your plans and sections and elevations and all the things you were classically trained to present are going to come from that model, right? So that's a whole new other type of software that came on.
Yeah, but the first, what you would call non-BIM 3D software, arrived in the 90s for architects. Software such as FormZ that I use a little bit in college, but most recently software such as SketchUp that is still used quite a lot by people in the architecture fields. They're not considered as BIM themselves.
Because they don't really have the data portion. They don't really bring you to the plans. They don't really bring the information.
Yeah, you don't draw big projects using SketchUp. Maybe some people do it on smaller projects, but still the most common process would be to use SketchUp for 3D modeling, but then to use AutoCAD for 2D.
So for me, though, I was kind of lucky. In the late 90s, I got on a bus that was early and pretty quiet that I would call CAD/CAM. So I'm like a CAD/CAM industry veteran where computer-aided design / computer-aided manufacturing became something that a certain little niche of producers picked up. I've been watching BIM get more and more proficient in parallel, and I got to admit, like in recent years, I used to think like, oh, our CAD/CAM 3D tools are years ahead of tools like Revit, for instance. Somewhere in there, like the Revit and building modeling industry started catching up in a big way and started doing a lot more integrated work. And can you tell us more about how that happened?
Yeah, sure. Well, I can talk about both a Revit expert and also an architect, where the BIM acronym comes in, which BIM stands for Building Information Modeling, but the important letter here is I, which stands for information. That's what actually differentiate a BIM from other 3D software. And the main idea of the information part of BIM is that the parameters are shared between views in a database, and the model and the plans are completely linked together. In this example, we modify the height of a door. It is modified not only in the elevation, but also in the 3D view and in the schedule. So Revit is extremely helpful for architects to create coordinated documents, and for engineers as well, of course.
And the architect typically starts the model, from what I've seen, in in supporting practice in the US, there are a lot of users that come down the pike, but the architect is really the one who jumps in, starts the model, gets it built.
In this example, we have a simple architecture model that we shared with the structural engineer. The engineer sends back a file that we proceed to load into our project as a link. The structural columns modeled by the engineer are now visible. There are actually multiple ways you can use Revit. Most people, when they hear about BIM, they think it's just super fancy, this super fancy protocol, as I've mentioned earlier on, with all these fancy acronyms. Some people might even get scared about it. But there's actually multiple levels of BIM that you can do. And for beginners, you can simply start with the first one. The first level of BIM is simply creating 2D sets of plan, but using BIM software such as Revit instead of AutoCAD, which helps to be more coordinated with less chance of errors. And then the second level of BIM is to push the process by collaborating with other professionals, clients, contractors to share models together, which makes it much more easy to build and again reduce the chance of mistakes on the field greatly. And finally, the ultimate BIM, the third level, would be to get rid of 2D plans completely and have some sort of a super model, super database that is shared by everybody, the architects, the engineers, the contractors, subcontractors, everyone involved in the project would be sharing all the information, everything would be connected. So most people are not quite there yet. And if you're getting started, it's okay that you're not at that level. You don't have to be there. But in a sense, that's the ultimate goal. That's what we hope will get to in the future. When you look back at the history of architecture, there are a few early examples of the highest levels of BIM before BIM was actually mainstream. Frank Gehry designed the Bilbao Guggenheim Museum, which opened its door in 1997. The building was so complex that they couldn't use simple CAD software or create 2D documents. BIM was still in its infancy and no mainstream softwares existed back then. So they had to use software made for fabrication of airplanes and boats. They used the software CATIA, developed by Dassault Systems. In a sense, that's the highest goal of BIM. Use the model to create a building without the need for 2D plans as the imperfect middleman. But today, the data and information components of BIM can be used for much more than just fabricating complex geometry.
We heard that Revit was really the mainstream, middle of the road. Mostly everybody's using it, but we weren't quite sure. So do you have any background information on were we correct to choose Revit as the primary or the first BIM delivery platform?
Yes, well, when it comes to architects and engineering for buildings, there's no doubt that currently Revit is the biggest software out there. And Autodesk purchased Revit in 2002, and since then the growth has been quite phenomenal. In this video, we can see the most searched BIM software on Google since 2004. ArchiCAD used to be the most popular, but as you can see, Revit quickly started to catch up, especially since it was purchased by Autodesk. Revit is in blue here, and it quickly started to catch up with other BIM software. It became the most popular in 2008, and since then the expansion didn't stop. These days, Revit is 4 times more popular than ArchiCAD, the closest competitor.
Architecture firms are many sizes, and in many times the Revit was for the larger firm and the smaller firm. Maybe to this day, a smaller firm may still be using good 2D software and doing good practice and generating great wood structures. So we have to stay pretty fluid in all those. I'm going to share here some awesome photos of a job site I was on recently of some really complex steel and mass timber hybrid interactions that was all created within ArchiCAD by a small firm. So just a quick point that although we're working on Revit as a really large section of the market, we're also working on interactions with many other softwares. And we also want to make sure that interoperability is a constant discussion among BIM topics, because the Revit user is really carrying the football for a really key moment in design, but it's not the end of the whole BIM progression.
But also sometimes BIM goes beyond the 3D, it goes beyond the architects in some of what I call jargon, like 4D and 5D, which 4D stands for assembly on site, and 5D means the cost analysis. There's multiple trends and extension of the technology beyond Revit itself, especially on the cloud. You have platforms such as BIM 360 by Autodesk. BIM 360 allows everybody to collaborate in BIM without the need for advanced software such as Revit. This platform doesn't allow modeling, but users such as project managers and clients can annotate the documents for collaboration. The content is always synced and up to date with all users. There are other cloud platforms by third-party developers such as BIMtrack, which allows BIM files from multiple softwares to be imported and annotated in the cloud. So again, that's moving toward the third level of BIM, the ultimate BIM, where everybody's collaborating. And I hope that the producers of steel and wood, of course, can share their content and help architects and other participants in the project. All right.
Awesome.
Well, thanks for having me.
Thanks, Nicolas.
See you later. Bye. Please like, subscribe, and stay tuned for upcoming Offsite Roundtables on the topic of BIM and wood in the construction industry.